Hello everyone, I'm Musa Yusuf Buhari, MD diet therapist. So today I would like to talk on lipid metabolism. This presentation is basically for students that are offering courses that has to do with nutrient metabolism in courses like microbiology, biochemistry, pharmacy, medicine and surgery, nutrition and dietetics, and so on and so forth, student in the community health, and paramedical courses in general. So, specifically, I would like to talk on lipid metabolism. Now, what do we understand by lipids? Lipid is usually a group of, it is one of the group of food that is consists of fat and oil. That is what we mean by lipid. And this class of food, which is lipid, it is insoluble in water. It is a chemical compound that is insoluble in water but soluble in organic compound such as ether and alcohol. When you bring a lipid or when you subject lipids into water, it cannot be dissolved. And as such, it is one of the characteristics that is showing this is a lipid. Lipid is being classified into different groups, such as we have what we call simple lipid. That is number one type of the or group of the lipid, simple lipid. We have complex lipid. We have derived or precursor lipid. These are different groups of lipid that we have. We're going to pick each group one after the other and see how this group differ from one another. Looking at simple lipids, this is a group of lipids in which an alcohol it is being esterified with the fatty acid to form a simple lipid. Common example is triglyceride. It is a form of lipid in which glycerol, which is an alcohol, it is being esterified with the fatty acid to form triglyceride, which is one of the neutral lipid that is being found in the food or in the body of living organisms or human being. It is a common example of simple lipids. Number two, we have what we call a complex lipid. This is a form of lipid in which it is triglyceride apart from the glycerol backbone that is being esterified with the fatty acid. It has in addition of different moiety that is being attached or bonded to the fatty acid group in one of the carbon atom. For example, phosphoric group. A phosphoric residue such as this is attached to it to form what we call a complex lipid. Usually, if we look at from the structure of the lipid, this is the structure or chemical structure of triglyceride. This is the fatty acid group. This is the carboxylic acid group of the acid, which is the functional group of the acid. This is the fatty acid chain, and then this is the alcohol group, which is the tri-carbon atom alcohol, usually the glycerol. This is glycerol, and then these are the tri-carbon carboxylic fatty acid that is being attached to it to form what we call the triglyceride, which is the first class of the lipid, triglyceride. Now, from the structure written on the board, as you can see, this is the simple lipid, common example of the simple lipid, which is esterified. This is the ester bond that is existing between the fatty acid and the alkanol, which is the glycerol backbone. This is the glycerol backbone, and then this is the ester bonding that is existing between them. Now, for the complex lipid, apart from being this esterification between the fatty acid and the alkanol, which is the glycerol, in addition, it has a phosphoric group that is being attached to one of the fatty acid moiety or group. This is the phosphoryl group or the phosphoric group attached to it. So now, in addition to this, if phosphoric group is attached to this, you can have this as your what? As phospholipid, which is a good example of complex lipid. We have, apart from the phosphoric group, other components can attach to this functional group and becomes other forms of lipid, like sphingosine or sphingolipid. Sphingolipid, it is a form of complex lipid that it involves the phosphoryl group and the nitrogenous group that is attached to the triglyceride molecule to become phosphosphingosine or sphingolipid. Now, coming down to the derived lipid, this is a form of lipid that is being derived from other fatty acid such as cholesterol. It is a multi-ring structure of fatty acid that is being formed to form a cholesterol. That is another form of lipid. There are various classes of the lipid, as we can see. This is another beautiful structure of one of the lipids that we have. For example, it is also an example of fatty acid. This Fa referred to as the fatty acid. So for you to be able to understand the concept of nutrient metabolism, it is very important to recall back to your organic chemistry from the basic O level. This will help a lot in understanding the concept of nutrient metabolism. This is choline, this functional group that is attached to this phosphorus group is called choline. So you can see this is the glycerol. Now, from this simple introduction of the lipid that I've introduced, it is expected that you should be able to distinguish between different class of the lipid as well. So furthermore, let us look into fatty acid, because we say that lipid consists of fat and oil. This fat, it is usually lipid that is solid at room temperature. It is referred to as the fat, while oil it is a lipid that is liquid at room temperature. So that's the difference between the fat and oil. Now, what are fatty acids? Fatty acids are also lipids. There are two groups of the fatty acid. We have what we call saturated fatty acid and unsaturated fatty acid. A fatty acid is said to be saturated if it has all the number of the hydrogen atom that is attached to the carbon group with a single bonding. It is called saturated fatty acid. And unsaturated fatty acid are fatty acid that they have presence of double bond and they are stereoisomers. Usually they have presence of either single double bonding in them or multiple double bonding. If the unsaturated hydrocarbons consist of the single bonding attached to it, it is so-called monounsaturated fatty acid. But if the fatty acid consists of multiple double bonding on in between the carbon atom that is more than two, is called unsaturated fatty acid. And a fatty acid usually consists of a long chain hydrocarbons with a functional group of carboxylic acid and the methyl group at the tail end. For example, let us look at the chemistry of this fatty acid as common examples so that we should be able to identify the differences or to distinguish the difference between saturated fatty acid and unsaturated fatty acid. If we can look at this carefully, this is CH3, that is the tail end of this fatty acid, and then this is the carboxylic functional group of the acid, that is the functional group of the fatty acid. Specifically, this is butyric acid, which is saturated fatty acid because in this chain there is no double bonding on it. It is single bonding. That is why it is saturated fatty acid. Now, this fatty acid, the carboxylic functional group is called the alpha carbon, while the methyl group, it is the omega carbon. So a fatty acid consists of the omega and the alpha carbon. The omega carbon, it is the one toward the end, that is toward the tail chain of the carbon of the fatty acid, while the alpha, it is the first carbon from the right, it is the alpha carbon. Now, this can help you in naming or identifying fatty acid. Where does it belong to and how you can name it before we go into the beta oxidation. Now, classical example of some of the saturated fatty acid and unsaturated fatty acid are as follows. For the saturated fatty acid, these are the examples. And for the unsaturated fatty acid, these are the examples, so that from the examples of them we should be able to know which one belongs to this group or the other. We have acetic acid, which is common example of saturated fatty acid. We have propionic acid, we have butyric, we have valeric, we have caproic, we have capric acid, We equally have lauric acid, we have mystric acid, we have stearic acid, we have palmitic acid. All these are examples of saturated fatty acid. They have single bonding in between their carbon atom. Then classical examples of unsaturated fatty acid, we have oleic acid, we have linoleic acid, we have linolenic acid, we have linolenic alpha and gamma acid. All these are examples of unsaturated fatty acid. In between their carbon atoms, there are presence of double bonding in them. So with this little introduction, this can help us in the subsequent class or in the subsequent presentation to be able to know when we come for the beta oxidation, how can this enter into beta oxidation and what happened to the fate of them when they form acetyl CoA and so on and so forth. So you wait in anticipation of my next video for beta oxidation and how we are going to identify this acid using alpha and omega naming system. So thank you very much for listening. Like, share and comment. I'm Musa Yusuf Buhari, MB Diet Therapist.